my very Korean high school class. And I will come back to it now to the main figures. Well, until it is ready, I will tell you about the very little problem. One of my colleagues, I said that he was trying to become a teacher, and his parents were teachers also, and he never knew if his grades would reflect his knowledge on that exact day, or if his grades were a little bit higher because usually he was a smart kid. The other one was a little less fortunate. He had changed. He became a bad example, tried to cheat both at exams and at homework. The girls, one of them, had a bad handwriting and was generally misunderstood and underrated because of it. The other one had a very artistic nature and always forgot some things at school. The central image is our chemistry teacher. He never had time to finish grading our papers, and he generally was subjective. He even admitted it. So we have thought of a system that would improve their lives and our lives. Imagine students graded equally, teachers that would have more free time and with kids in free time activities, a way to organize their paperwork, a way for teachers to simply correct the exams to a click on their computer, and a way to never be misgraded on an exam paper. Smart is this dream come true. We use for our solution a pen, with which the students write, the e-book, of course, a laptop or a desktop computer for the teacher's desk, and a web server. This would be the presentation of our system. I will now ask my colleague in the Department of Software to describe a little bit more about our system.
Hello. I would like to say a few technical words about our system. In brief, this is our system. It is based on a multi-tier architecture. We will start from left to right. The first tier, the left one, is comprised of many e-box computers to which electronic pens are connected. The electronic pens are very similar to traditional pens. They write on normal paper, yet they do have a capture device so that data is forwarded to the e-box computer. There on the e-box computer, handwritten data is transformed into typewritten text, and later on it is forwarded to the next tier via Bluetooth communication. The next tier represents the teacher's computer, where the teacher may view all students' data in real time and also may view recognized text. He may also organize exams. He may look for cheating, or he may monitor the class in real time. All data collected by the teacher computer is then forwarded via Ethernet to a school server, where all data, including grades and handwritten text and typewritten text, is stored for the next tier. The next tier being the web tier. With the help of this web tier, the students and the teachers and many other people can view the school results. For instance, teacher may view their exams, the grade exams. Students may view their grades, may view what the teacher has to say about their exams, while other people that are not involved in the education process may view school statistics, for instance. Moving on to the next slide, we could see there's a bit better detail on the first tier, namely the e-box image. I will tell you a few words what components did we add in the OS design, namely the C runtime, the Bluetooth stack to communicate to the next tier, the USB host controller, the fidget driver, which is provided in the competition gears, and we use the fidget to feed back some information to the students, like how much time they have on the exam. The most important part of our e-box design is this electronic pen driver, which is developed by ourselves, so we could capture recent handwritten data. It is based on the WinCD HID mouse driver and the manufacturer's documentation. Moving on, these are the two main applications that are run on the e-box computer, namely the launcher, which is an application that continuously waits for Bluetooth connection, and upon receiving one, launches as many instances of the rocket, as we call the second application, as there are electronic pens connected to the e-box. So we achieve scalability with this feature. We also achieve robustness with this design. The rocket is the application that actually does handwriting recognition, and my colleague will present it to you shortly. The first thread of this application is the data acquisition thread, and the whole system is actually organized in multiple threads, so that we benefit from multi-threading. For instance, you do not have to wait for data to be classified to write another piece of text. Data is classified as time is available to the classifier thread, as you can see. My colleague Vicky will now present you more technical details about this application.
Thank you, Taylor. So, we achieved scalability through our hardware here. So, we skipped over the first thread, which is the data acquisition thread, which communicates with the outside environment. It receives pen data and Bluetooth messages. And the data is transmitted to the preprocessing thread, which has the role to remove the variability in each different handwriting style. Each person has a different handwriting style. We do this by using some classical transformations. You can see them in the picture. We have removing blank, removing skew, and moving. Also, we use some original algorithms implemented by us, such as baseline detection, and some original heuristics for delayed strokes, because the delayed strokes was a big problem in the handwriting recognition. And the gesture recognition module, which also uses heuristics to determine underlining for some typos and crossing over some part of the text to remove it. Moving on, we are in the classifying thread that does all the hardware. Here we use statistical models, hidden Markov models, which are borrowed from speech recognition. We also use a large